Alright, in this video I want to look at a couple nice little application problems that involve solving by factoring. A couple problems that get you thinking at least a little bit more of situations where you can solve a problem by factoring. So the first one's fairly straightforward, but it says in the equation y equals x squared minus 9/16, which is a value of x when y is equal to 0. So in other words, that's asking us if y is 0, what is x? So I have 0 equals x squared minus 9/16. And notice I have an x squared here, so I'm going to want to solve this by factoring. Okay, well, this looks eerily like a difference of squares, because this is a perfect square here, and I know that 9 is a perfect square, and 16 is a perfect square. 3 times 3 and 4 times 4 respectively. But it's a fraction. I don't deal with fractions often. Well, we can use our difference of squares still. Because is 9/16 itself a perfect square? Well, sure. 3/4 times 3/4 is equal to 9/16. So I see that 9/16 is a perfect square because I can take the same number of 3/4 times itself to get it. So that means I can factor this x squared minus 9/16 as x minus 3/4 times x plus 3/4, and that is equal to 0. So then by the zero product property, I can set each of these factors equal to 0, and then I can solve for the value of x, and I get x is equal to a positive 3/4 or a negative 3/4. And so, what do you know? C, 3/4. That is a value for x that makes y 0. Let's move on to this problem, which is even more of an application-based problem. Think more of what these equations are doing. So we've got Ben diving off a 36-foot platform. Crazy guy. That's too high for me, but apparently not for Ben. So he's got the equation h is equal to negative 16t squared plus 14t plus 36, modeling the dive, kind of the trajectory of his dive. How long will it take for Ben to reach the water? So just draw what that equation is modeling. We've got Ben up here on the diving board, 36 feet up, and then you've got your pool down here. So this is 36 feet. And they're saying that equation, which is h is standing for height and t is standing for time, as he jumps off his height, you can find his specific height at a specific time by plugging in some value for t. So I could plug in t equal to 5, plug that into the function, and give me h is equal to some height. And it's kind of interesting that that equation, which we know is a parabola, so it has a shape like this, models what you would expect a guy jumping off a platform to look like. It has that nice swoop as he goes down. So anyways, how long does it take him to reach the water? Well, when he reaches the water down here, what is his height at this? Well, that would be what we call ground level. So the height is equal to 0. And when h is equal to 0, what is t? Well, what if I say in my equation 0 is equal to negative 16 t squared plus 14t plus 36, and that equals 0 because h is 0. Hey, notice this is a problem we solved by factoring. I have a trinomial, and it is set equal to 0. So if I can factor this, I can use the zero product property. So I'm going to go ahead and do that. And I do notice in this polynomial, it's got some big numbers, but I can factor out a 2 from everything. So I factor out a 2 and I get negative 8t squared plus 7t plus 18. So I factor out a 2, I factor out a greatest common factor first. I now have this trinomial with a lead coefficient of negative 8. So I'm going to try the dividing out method, and I'm going to multiply by negative 8. 18 times negative 8 gives me negative 144. And I'm looking for factors of negative 144 that add up to 7. And I already thought about this a little bit before, actually, because dealing with such big numbers, it might be difficult to find this. But it is, in fact, the two numbers being 16 and negative 9. All right, so I jump right to the factors 8t plus 16 times negative 8t minus 9. But then by the dividing out method, I have to divide one of these by the lead coefficient of negative 8. So in the end, I'm left with 2 times t minus 2, after that first factor is divided by negative 8, and then negative 8t minus 9. And I'm looking for the value of t, not just to factor this. So I set each of my factors equal to 0. T minus 2 is equal to 0. Negative 8t minus 9 is equal to 0. Notice I didn't have to set 2 equal to 0 there because that does not involve a variable, so I'm not going to get a solution out of 2. So I now have t is equal to 2, and then over here, add 9, negative 8t equals 9. So t is equal to negative 9/8 after I divide by negative 8. But I'm dealing with a real-world problem here. We don't really have negative time. So that means it can't be this solution of negative 9/8 seconds. Instead, it has to be this. So after 2 seconds, Ben is going to hit the water.